Welcome to this video all about exponential graphs. You can find these questions as a PDF on mathsupgrade.co.uk. The first question is a non-calculator for 4 marks. We have to complete the table of values for y equals 2 to the x. So this is known as an exponential graph, since x is a power of 2. It's an exponent of 2. So all I do, I just substitute each of these values for x into this equation and see what I get for y. The easiest numbers to substitute into here are these positive numbers here. Okay, so the number 1's already done for you, so 2 to the power of 1 is equal to 2. And so let's look at 2 to the power of 2. 2 to the power of 2 would be 4. So that would be 4 there in that table. This would be 2 to the power of 3, which would be 8. Now the rest of these numbers, 2 to the power of 0, anything to the power of 0 is the number 1. So this would be 1 here, and this is 2 to the power of negative 1. This is known as a reciprocal, so this is the same as 1 divided by 2. 1 divided by 2 is 0.5. The next part of the question, I've got to draw the graph of y equals 2 to x for the values of x from negative 2 to 3. So all I do now is I plot these values that I had here in this table onto this grid, remembering to go across for x and up the y-axis for y. Plot them as neatly as you can, using a sharp pencil for each point, and then joining up with a nice smooth curve from edge to edge on the grid. And that is what you'd get there for 4 marks. The rest of these questions are all calculator questions. Question 2 is 2 marks, and I have to sketch the curve of y equals 2 to the x. I've got to give the coordinates of the points of intersection with any axes. So y equals 2 to the x is an exponential graph, since x is the actual power here, and it will cut always at an intercept of 1. Since when x is 0, so when x is 0 here on the y-axis, x is 0, 2 to the power of 0 is equal to 1. So y is always going to be 1. It doesn't matter what base number you have here. The graph will look like this. Make sure your graph does not touch the x-axis here. It approaches the x-axis, gets closer and closer, but never actually meets it. Should be a nice smooth curve for 2 marks. Question 3. Given the graph of y equals k to the x, where k is a positive constant. Let's remember this is a constant here, okay? Not necessarily a whole number, not an integer, but a constant. That means it doesn't vary. So this is a fixed number for k. The question states, 2 marks, find the value of k. Find the value of k. Now, you can find the value of k from when x equals 1. When x equals 1, right, that means that y will equal k to the power of 1. So y will equal k. So when x equals 1, the value of y is actually what k is. So all I do here is from my x-axis, I go up from the value of 1 vertically until I reach my curve. Then I go across to the y-axis and I read off that value. Okay, so the value there you can see is a half. So that is my answer there. Y equals a half to the power of x. So k equals a half for 2 marks. In question 4, I'm told that Louis and Robert are investigating the growth in the population of a type of bacteria. They have 2 flasks, A and B. At the start of the first day, there's 1,000 bacteria in the flask. The population of bacteria grows exponentially at the rate of 50% per day. Show that the population of bacteria in flask A at the start of each day forms a geometric progression. So what I'm going to do in this question, I'm going to underline the key information here. So that's the fact that there's 1,000 bacteria in the flask A. There's the rate of growth, 50% each day, and I need to show that it forms a geometric progression. So this question involves geometric sequences. Okay, I'm going to split my working out up into 2 sections. Here I'm going to do I'm going to find out how much population is in day 1, day 2 and day 3, and then I'm just going to write a sentence to summarise that and give my reasoning as well. That's 2 marks. So in day 1 we're told there's 1,000 bacteria. That increases by 50%. So 50% of 1,000 is 500. So that's 500 there. So in day 2 there's going to be 1,500. Now 50% of 1,500 is 750. So if I add 750, I get 2,250. So that's increasing by 50%, increasing by a half every day. Now, if it's a geometric sequence, it will have a constant ratio, right? So the ratio between different days will always be the same. So let's find the ratio between day 2 and day 1. In other words, how much has it increased by from day 2 to day 1? Well, it's increased by 1,500 divided by 1,000. So that's the rate of increase. So it's increased by a factor of 1.5. Similarly, from day 3 to day 2, 2,250 divided by 1,500, that's 1.5 again. So it's got a constant ratio. Right? So I'm just writing a sentence here. Since the ratio is constant at 1.5, the population forms a geometric progression. And that's 2 marks there. In part B, I'm told that the population of the bacteria in flask A, so still flask A, at the start of the 10th day is K times the population of bacteria in flask A at the start of the 6th day. Find the value of K. So if you remember, on the first day there's 1,000 bacteria. On the second day there's 1,000 times 1.5. The second day there's 1,000 times 1.5. On the third day there's 1,000 times 1.5 times 1.5 again. So on the 10th day there'll be 1,000 times 1.5 times 1.5 times 1.5, basically times 1.5 10 times. So that's 1.5 to the power of 10. Now on the 6th day there'll be 1,000 times 1.5 to the power of 6. So if I need to find the value of K, what I can do is I can just divide these two through, and that will give me 1.5 to the power of 10 divided by 1.5 to the power of 6. Then if I use index laws, since I'm dividing the same base with different powers, I can just subtract the powers, subtract the indices, and that will give me 1.5 to the power of 4, which with a calculator is just 5.0625. So that there is the population, that there is how much greater the population is from the 10th day compared to the 6th day as a ratio. That's 5.0625, and that's 2 marks for that question. If you didn't understand what I've done here, be sure to look back either at standard form or just at index laws on the video on this channel. In part C, it says at the start of day 1 there's 1,000 bacteria in flask B. So they're on about a different flask now. The population of the bacteria in flask B grows exponentially at a rate of 30% per day. So in flask B it doesn't grow as fast, it's 30% growth rate, whereas in flask A it was 50% growth rate. Sketch a graph to compare the size of populations of bacteria in flask A and in flask B. So what we're going to do here, we're going to draw a graph. In the graph we're going to have population against time. So population on the y-axis, time on the x-axis. Okay. Now the time here on this axis. So this is going to be the start of day 1. So that's where the intercept is going to be, the start of day 1, and then we're going to have obviously start of day 2 a little bit later on. Okay. So we don't need to give exact values here, but I'm giving exact values for the intercepts and for other key information which you'll see. So flask A, we know there's 1,000 at the start of the day. And then we know at the start of day 2 there's 1,500, right? So I'll just put that on there. I don't really need to have any scales on the axes, okay, because it's just a sketch. Now for flask B, I know that since it's a rate of 30% growth, that means it starts with 1,000 bacteria. So it starts exactly the same point here, but it'll only grow by 300 on that first day, since that's 30% of 1,000. So on day 2 there'll be 1,300 bacteria in flask B. So you can see 1,300, it'll be lower than flask A, and I've just labelled those values on. You may not have to do this in the exam, but I've done it for you here just to show you that flask B will be a much shallower gradient than flask A. The important things are here is that the intercept is 1,000 for both of them. That's really important. And the other important thing is this line is lower down, it's less steep than flask A. That's the critical thing here. The whole question there was worth 5 marks. Be sure to check out the clips on index laws if you're unsure on how to do any of these questions. Also, video clip on geometric sequences is also very useful there for the start of that question. Question 5 is worth 4 marks. I'm given a sketch of a graph y equals pq to the x. I'm told that q is greater than 0, and I'm also told that these 3 coordinates are all on the graph. So the first coordinate is 0, 5, second coordinate is 2 and then k, which I don't know what it is, and the third coordinate is 4, 405. I need to find this value of k, so I need to find this y coordinate here. For 4 marks then. Okay, so what I'm going to do here, I'm just going to substitute each of these coordinates in turn into this equation to figure out what I can from this equation. Okay, so I'm going to first of all find the value of p, then I find the value of q, then I can find the value of k. So here's my 3 coordinates here. Here's my equation. Let's substitute the first set of coordinates 0, 5 into my equation. So you can see here x equals 0 and y equals 5. So put y equals 5, that becomes 5 equals pq, and x is 0, so what 5 equals pq to the 0. Now, since any base which is raised to the power of 0 is equal to 1, this is the same as 5 equals p times 1. So 5 equals p. In other words, p is 5. Straight away I found p is 5. So my equation is now y equals 5q to the x. 5q to the power of x. Now I'm going to substitute this coordinate here, 4, 405. When I substitute that into this equation, I should be able to find the value of q. So doing that, I'll get, since x equals 4 and y equals 405, I'll get 405 equals, p is 5 now, so 5q to the power of x, so to the power of 4. I'm going to divide both sides of this equation by 5. That gives me 81 equals q to the power of 4. Now I need to find the 4th root of 81. On your calculators you can do this quite easily. So q equals 3. In other words, 3 to the power of 4 is 81. So q definitely equals 3. The last thing I'm going to do now, since I know the value of p and I know the value of q, so basically I know this whole equation now. I know that y equals 5 times 3 to the x. 5 times 3 to the x. So now I can substitute this coordinate in, this last one here, into this equation that I've been given, and I can find the value of k. So this coordinate, x equals 2, y equals k. So y equals k, so k is y, k equals p, which is now 5, times q, which is 3, and x, which is 2. K equals 5 times 3 squared. 3 squared is 9 using BIDMAS. 3 squared is 9. 5 times 9, 45. So k equals 45. Let's see if that's a sensible answer. Well, k is my y coordinate, it's the height here. And now here the height was 5. Here the height's 405. So it's going to be somewhere in between there. So 45 is a reasonable answer. The whole question there was worth 4 marks. Question 6 is just 1 mark. The equation of the curve is y equals a to the x. A is the point where the curve intersects the y-axis. State the coordinates of A. So let's just sketch a curve. Okay, let's remind ourselves the y-axis is this axis here, and that's where x equals 0. So this y-axis is also called the x equals 0 line, since the horizontal distance is 0 for this axis. So x equals 0 there. So to find the coordinates of this point here where it intersects, I just need to find x equals 0, put it into this equation. So x equals 0 into this equation. So when I put it into that equation, I'll get a to the power of 0, and anything to the power of 0 is equal to 1. Even if it's a negative, it's still going to be 1. So at that point there, x equals 0 and y equals 1. In other words, that's where it intercepts the y-axis. That's true for any exponential graph, like I said in the first question on this booklet. All exponential graphs intercept the y-axis at 0, 1. Be sure to check out my other video files on this channel for further support. Thanks for watching.